We have learned how to name some of these compounds, particularly the covalent compounds. We can now discuss their relationship to air pollution and air quality. The reason we learn the names of these compounds is because they are the types of compounds that actually exist in air and are pollutants. I'm going to list some of the major ones here, starting with carbon monoxide or CO, and now you know how to name that compound. This is colorless and odorless, so it's particularly harmful that you can inhale without even knowing it. We usually get carbon monoxide when we burn something incompletely, so meaning that you're doing a burning where there's not enough oxygen. This happens, for example, when you run your car in a closed garage, so the amount of air that's available in the garage is less than what you would expect in open air in a parking lot, for example. And a lot of other old combustion equipment like kerosene and gas cookers tend to release carbon monoxide as well. Lead is another one. This is a metal, but it exists as an ion in this case, and it's generated by mostly industrial processes. It would get into air in very small quantities, but it's actually very, very toxic. In the past, we've used lead in gasoline, but once we learned that it was quite toxic to the human body and it sort of lasts for a long time in the bones, the amount of lead has slowly been removed, and now we don't have lead anymore in gasoline. So they are found as ionic compounds like lead oxide and all of these other lead compounds, and I do expect you to be able to name them now that you learn how to name ionic compounds. Nitrogen oxides, which has the generic formula NOx, is a series of compounds that are generated from combustion, particularly from automobile gasoline combustion. It's given this generic formula because that X could be either 1, 2, or other numbers, but the most common one is NO2, which is nitrogen dioxide. It's found in air, and when it combines with water, it could actually generate nitric acid, and then when the water comes down as rain, we have acid rain, which could react with metals, which generates a lot of damage. Ozone is another covalent compound that exists as a gas. Typically, we don't find it at the level where we're at in the atmosphere. It's usually found in much higher level. However, what we are talking about here is what we call ground level ozone or tropospheric ozone, which is ozone found at low level in the atmosphere. And this is because it's a reaction between those NOx's compounds and things we call volatile organic compounds or VOC. These volatile organic compounds are generated from industrial processes and some cars and so on. And in the presence of sunlight, these two compounds will react to produce ozone. Ozone is dangerous for humans if breathed in. You can even transfer them to areas where there's not a lot of these industrial plants or cars because it could be carried by wind because it's a gas. SO2, sulfur dioxide, another one of these gaseous compound that's toxic. With water can produce sulfuric acid, which is a really strong acid that can damage a lot of things around us, including metals. Obviously very dangerous if you're exposed to strong acids. And a generic class of materials called particulate matter, which is basically just things that are small, but they're big enough that when breathed in could cause problems for our cells, other biological tissues. So here is a comparison of the particulate matters that we are worried about. There are two groups of them, PM 2.5, and the reason they're called that number is because their size is less than 2.5 microns. And then there's PM 10, which is things that are smaller than 10 microns. In that group of category, you'll have things like dust and pollen, mold, and so on, whereas with the PM 2.5 is smaller things like some metal pieces, they're tiny. This is just a comparison to show you how big the human hair is comparison to these particulate matters, but they are found around us, and when you breathe in, particularly in areas where a lot of them are produced, they generate a lot of health issues, as you might imagine. The EPA, or the Environmental Protection Agency in the United States, created something called an air quality index, or AQI, which is a measure of how much of these air contaminants or air pollutants are present in the air around you. And you can actually search this. If you go to the EPA website and search for AQI, you'll find these table that tells you if your AQI for that particular day is good, moderate, unhealthy for certain groups like people with asthma and so on, unhealthy in general, or very unhealthy or hazardous. There are monitors that are placed in different parts of the United States that monitor these air pollutants daily. In fact, if you work for organizations that are large enough, you have to submit these information to the AQMD, which is Air Quality Monitoring Detection, to tell them what is the quality of air in the area where the organization is located. Okay, so here's just a quick example to help you apply some of these information into real life. So for example, let's say you live in a city and you're asked if your air quality is healthy or unhealthy. In this case, they're asking for which one has an unhealthy air on that day. It's really pretty straightforward. So there's 5 different cities listed here, A, B, C, D, and E, and the AQI value is given here. So all you need to do is just place it on that scale and find the ones that are 151 or higher. That would be considered unhealthy air. And so if we look here, really only D has unhealthy air. C has unhealthy air for sensitive groups, so those people who have pre-existing respiratory problems. Probably if you investigate further, you'll find that that area perhaps have like industrial plants and other issues that cause the contamination level to be higher. As we just talked about earlier, there's a lot of these pollutants that exist in our air. And this happens because when the Industrial Revolution started back in the 1800s, of course, people weren't thinking about the fact that a lot of the fossil fuel that was burned will generate all of these gases that we don't want and could be dangerous for us or the planet. Now we are a lot more informed about the problems that happen when these fossil fuels, other types of fuels, are being combusted. So there is this movement of green chemistry, which is the idea of trying to start with something that is safer to begin with, so that when we consume it or when we do these type of reactions, what we produce are products that are safe and could easily be reused or discarded, but it's not going to be generating a big problem like toxicity in air or pollution or greenhouse gases and so on, right? And so that's the whole concept of green chemistry.